All right, what is going on? We're going to look at Unit 1, Lesson 13, Polyhedra. Today we're going to investigate Polyhedra. So by the end of today, I'm hoping that we can describe the features of polyhedron using mathematical vocabulary. That's what we're going to be learning today. We know the difference between prisms and pyramids, okay, two types of polyhedra. And then I want you to understand the relationship between a polyhedra and its net. What does that mean? We're about to find out. All right, so let's dive in. Activity 1.1, what are polyhedra? Here are some pictures that represent polyhedra right here on the top. And here are some pictures that do not represent polyhedra. So go through each one of these. We have sort of a cube, and we have this shape. We have a bunch of really awesome shapes. Those are polyhedra. But then notice down below we have a sphere and a cylinder, and this awesome thing, and kind of something that looks like a box with its top removed. So let's look at some features that will help distinguish a polyhedra from other figures. And just so you know, like this is a polyhedra right here, this thing I'm holding. This is not a polyhedra, this is like a cylinder, right? So these are a couple things that are a polyhedra. This pyramid, if you notice this pyramid, but then we have something that's a cone. You know, a cone is not considered polyhedra. All right, so let's look at some characteristics of polyhedra. All right, so here are some characteristics of a polyhedra, and you guys can write this in your book, but I'm going to keep it off to the side to make this a little bit. I mean, definitely write this in the space down below for number 2. Polyhedra are made of polygons, and if you notice that all the polyhedra on the top are composed of these polygons, right? Polyhedra don't have any unattached edges. So if you look at this box over here, we were mentioning before that it doesn't really have a top. Well, unattached edges, you need to close that up, make sure you don't have an opening like that. Non-polyhedra sometimes have curved or round surfaces. Absolutely. You won't find that in polyhedra, but non-polyhedra sometimes have that curved. We have a cylinder there and a sphere. Definitely have curved surfaces. And also some non-polyhedra have a face that is not a polygon. So here on the sphere, we have a face that's a circle. We know a circle not to be a polygon. A polygon has those straight sides and the vertices that only connect two line segments together. All right, awesome. And great. So now I really want us to look and investigate prisms and pyramids. And just to give you some examples, these are prisms, okay? These are both prisms. They're considered prisms. And these are pyramids, okay? These are types of polyhedra. You notice that these are composed of triangular sides. This one has a triangular base. This one has a square base. And then for these prisms, right, this is also known as like a box. We have rectangular sides. In this case, we have a square bases, right? These bases are exactly the same. Hexagons for bases here, right? Exactly the same. And then rectangles all the way around on the sides. Reminds me of corn. It really, really does. So if we look in our book, right, we have some prisms. Now the very first one looks like this, right? It is a triangular prism. It's got triangles for the edges. And if you notice right here on the edge here, there's a triangle on the top and a triangle on the bottom. You're going to have to really visualize that this is the shape that we're talking about. Triangles on both sides and then rectangles on the sides there. Next we have something called a cube. And a cube is a pretty cool type of prism. It's got squares on all sides, right? All of the surfaces are squares on a cube. Now the next one is a triangular prism. And it's just like A, right? It's the exact same thing, except it's set on on its side. So triangular prism. The next is a pentagonal prism. I don't have that one here, but notice the sides are all rectangles. Then we have a rectangular prism, which is going to sort of look like this, right? It's got rectangles as sides and rectangles as the base and the top. These are technically squares. Squares are technically rectangles. And F, look at that. We have F as a hexagonal prism. If we can get this to focus, I don't think it's going to want to focus on that one. Now, there are some polyhedra called pyramids, and if you notice, these are totally different than what we just described. And these have a polygon as a base, but there's not another polygon on the top. They all come to a point at the very top, so we call those pyramids. You might know, you might think about the pyramids of Giza or any of those pyramids in ancient civilizations. That shape's been along for a long time. All right, so let's look at the prisms. What are the characteristics and the features? So what are the characteristics and features of a prism? Let's take a look here. I'm looking at this, and I'm thinking that we can describe this as a prism has rectangular faces. Right? Some of the faces are parallel to one another, and a prism may have two faces that are not rectangles. Here's an example of a prism that does not have rectangular faces. And we call these bases, right? These are triangles, and the sides, these faces, are all rectangular. Now let's look at the pyramid. We can describe this pyramid. We can describe the pyramid as a triangle on all of its sides, or all of its faces, or all but one of its faces, right? So this one has all triangular sides. This one has all triangular sides or faces, but this one has a triangle base, and this one has a square base. This is still a pyramid. It's going to have all triangular sides, or all except one triangular side. Okay, and all the triangles, they meet at a single vertex, right? They all come together at the top here. Which of the following nets can be folded into pyramid P? Okay, so pyramid P looks like this, all right? And we have a series of nets, 1, 2, or 3, and we have to really decide which one of those we can turn into pyramid P, okay? So I actually have these nets. This is called a net. I have them all printed out here. I'm going to cut these out, and if we fold these in such a way where we can get that prism or that pyramid, then we're going to be in pretty good shape. Sometimes you just have to go ahead and cut these out and fold them up. All right, here's the first one. It kind of looks like a cool emblem, cool superhero emblem or something of that sort. I'm going to fold these up, and let's see if this is going to create pyramid P. Okay, so here is what I've come up with. I put it together, but it's got an open base, and there's no way I can fold it where the bottom is going to close. So this first one is not going to really work out. Cut, cut, cut. So even though we have triangles all joined together in a certain pattern, we're not going to always get what we want, right? It's not going to always fold out to be a triangular prism. So here's the next one, and I'm trying to fold this together, and I actually can. Oh, very surprising. I actually can fold this up and get pyramid P. And it looked like this. Originally, it looked like this shape right here. And finally, is this one going to work? I'm wondering. I know we're all dying to know. Is this one going to also fold up to be pyramid P? Let's find out. Let's find out together. Got my wonderful cutting skills here. I've got that cut out, and I'm going to fold these on each of the lines. I wonder, would you look at that? So this one actually folded up too, and this is like kind of my favorite style, right? Because you just fold these up, and then boom, they all connect at the top. So keep an eye on this shape right here, this pattern. That one's going to make yourself a pyramid every time. Were you guys surprised about this one? I was a little surprised, you know, but yeah, it actually does work out. And sometimes you just have to cut these nets out and figure and connect them and actually do it. All right, I'm going to give you one more polygon to consider. This is the net of said polygon. And let's cut this out and see what shape we can get, what polygon we are going to be able to assemble with this net. Now, a net, of course, is going to be the two-dimensional representation of a three-dimensional shape. And this net is going to be a certain polygon that I'm sure all of us are going to be familiar with once we put it together. But, you know, notice that it is composed of 6 squares. If you notice, there's 6 squares. And when we put these together, let's find out what this shape truly becomes. All right, so I have it cut out. And let me fold up these sides. Folding it up, nice and neat, sort of. And what shape is it going to be? That's right, you guessed it. You did guess it, ladies and gentlemen. It's going to be a cube. It's going to be a cube. Now, if you notice, it's just made out of paper, but it represents a three-dimensional shape, right? 2 dimensions. The net is the net looks like this, 6 squares. But if we fold it up, it represents a three-dimensional shape called a cube or a rectangular prism. Right, right. So here's the thing. That net of a cube can look different. Here's a different version of the cube. But notice the 2 flaps on the side. You have the 8 squares going up the middle. And then these 2 flaps on the side is one sure telltale way that to identify a cube, okay? There are, like, I think 11 different ways to create a cube using nets, but that is absolutely one that's always going to work. If you have those 4 up the middle, and then you have the 2 flaps on either side. It doesn't matter where they are. Doesn't matter where they are. All right, so let's look at the summary, because this is super important. We learned a lot of terms today. And I just want to make sure that we kind of get the idea of each one of those terms. So the polyhedron, of course, is a three-dimensional figure composed of faces, right? It's composed of faces. Each face is a filled-in polygon and meets only one other face along a complete edge. So here is a complete edge. This is the complete edge. Here is a face. There is a face. They're only going to meet right there. The ends of the edges meet at a point called vertices, or the vertex, right? That single point right there, where those edges, 3 edges meet, 1, 2, 3, is going to meet right at a vertice. Okay, same with these, right? Polyhedron, we've got the filled-in polygons and meets. We've got the filled-in polygons, and some terminology is the edge is that corner piece, the face is each one of the sides, basically. And the vertex is that piece where they all come together, where all those edges come together. Here we have a pyramid, and it's the same idea, right? The same idea with the vertex, where the edges meet, the edge where the polygons meet, and then the face, right? The faces. A polyhedron is always an enclosed three-dimensional region. A polyhedron always encloses a three-dimensional region, absolutely. So we can actually fill this up. It has volume. We can fill this up with square units, or we can fill it with water or anything, right? So it's always going to enclose a region. Here are some other drawings of polyhedra. The plural of polyhedron is polyhedra. Awesome. Okay, so we need to know a couple of these terms here. A prism is a type of polyhedron with two identical faces that are parallel to each other and sometimes called bases. The bases are connected by a set of rectangles, sometimes parallelograms. A prism is named for the shape of its base. For example, if it's a pentagonal base, then it's going to be a pentagonal prism. If it's a rectangular base, just like this one, we've got rectangles on all the sides, and then the bases are going to be rectangles. If we have a triangular prism, also known as a slice of cheese, as in this illustration here, right? We're going to have triangles on both sides, and all of the other faces will be rectangles. And they don't always have to be the same measurements, right? Those rectangles are going to change depending on what those triangles look like. But the triangles are always going to be identical. And lastly, we have a pyramid. It's a type of polyhedron that has one special face called the base. And all other faces are triangles that meet at a single vertex. So this is the base. In this example, the base is a triangle, but all the other sides are a triangle, or all the other faces, and it meets at a single vertex at the top. Now, you can have a square pyramid or a rectangular pyramid. By the shape of the base, they have has triangular sides, and of course these all meet at the very top at the vertex. And then finally, you have a net, which is a two-dimensional representation of a polyhedron. It's composed of polygons that form faces of the polyhedron. In here we have the example of the cubes, of course, with the 6 faces, 1, 2, 3, 4, 5, 6, and it's composed of 6 squares. You can cut them out and fold them and put them together to make a model of a polyhedron. And in the cube, every face shares its edge with 4 other squares, right? In the net of a cube, not all the edges of the squares are joined with another edge, but when it's folded up, however, these open edges will form and create another edge, right? Edges here, edges, edges, edges. And lastly, this last note, it takes time and practice to visualize the final polygon just by looking at the net. Absolutely, it takes practice. So keep practicing, keep it up. You'll get there, you'll get it. But this is just an introduction, and we're going to be working with nets and polygons and polyhedra as we go through the next few lessons. All right, we'll see you next time.